Hi everyone, in this video I am going to teach you on how to solve optimization problems in differential calculus. I have two examples here for you. Let's answer the first one. So here, a farmer has 42 meters of fencing and wants to fence off a rectangular field that borders a river. The farmer needs to fence along the river. What is the maximum area of the field? Okay, so let's just say, imagine this is the top view of the river, and then this is our rectangular fence. Okay, so let's just say that the length is y and the width is equal to x. Okay, so I know we're computing for the maximum area here, but first we will be using the formula in computing for the perimeter of the rectangle. So that formula is P equals 2L plus 2W. P is 42 here. L is being represented by y. Now there's only one length here that we will use, so that's y plus 2x. Okay, so let's express this equation in terms of y. We will move this 2x to the left side, and when we do that, that 2x will become negative. So that's subtraction property of equality. So that's our equation 1. So for equation 2, we will use the formula in computing for the area of a rectangle. So that's length times width. So area equals length, which is now 2x minus 42. Again, y is the length, but according to equation number 1 rather, y equals to 42 minus 2x. So that's 42 minus 2x times the width, which is x. So this is 42x minus 2x squared. Okay, so for this one, the next thing that we will do is we will find the derivative of 42x minus 2x squared. So the derivative of that is 42 minus 4x. Now for this, let's compute the value of x. So negative 42 equals negative 4x. And let's divide negative 4 on both sides. That is going to give us 42 divided by 4 is 21 over 2. And 21 over 2 is 10.5. So this is 10.5 equals x. So now we have the x. We need to solve for y using equation 1. So 42 minus 2 times 10.5. So 42 minus 2 times 10.5 equals 21. So now that we have the length and the width, we can now solve for the area, the maximum area. So for the maximum area, it will just be 10.5 times 21. So 10.5 times 21. Alright, so that will be equivalent to 220.5 meter square, or square meter. So that's for the first example. Let's go to the second one. A piece of cardboard measuring 24 inches by 20 inches is formed into an open top box by cutting squares with a side length x in from each corner and folding up the sides. Find the largest possible volume of the box. Okay, so imagine this is the cardboard. And we need to cut this side, and then this side, and then this side. So each length of the square is being represented by x. Right? So that means the new, this is 24, by the way. So which means this is 24 minus 2x. this is 20, so this is 20 minus 2x. Alright, so the length is equal to 24 minus 2x. The width is 20 minus 2x. Now we need the height. So obviously you will fold that, and when you fold it, the height, it will be represented by the x. Okay, now first let's solve for the volume of this one in terms of x. So this is x times 24 minus 2x times 20 minus 2x. So length times width times height, or height times width times length. Okay, we just need to multiply these three dimensions. Okay, so let's multiply this first. So 24 times 20 is equal to 480. And then minus 48x minus 40x. 24 times 2 is 48, 2 times 20 is 40, plus 4x squared. Now let's distribute the x, and at the same time let's combine these two. So this is now going to be 480x minus that's 88x squared plus 4x cubed. Now let's just check if my computation here is correct. 24 times 20 is 480. 24 times 2 is 48. 2 times 20 is 40. 2 times 2 is 4. Alright. The next thing that we will do here is we need to find the derivative of this one. Okay. So d over dx. That would be equal to 480 minus, so 88 times 2 is 176 plus 12. Don't forget the x plus 12x squared. And then let's check if we can simplify this equation. Okay, I believe all of these three terms are divisible by 4. So let's divide all of them by 4. So 480 divided by 4 is 120. This is 44x plus 3x squared. Now, the next thing that we will do here is to solve for x, obviously, and that means we need to use the quadratic formula. So x is negative b plus and minus square root of b squared minus 4ac all over 2a. Now remember, these are a, these are b, and these are c. Okay? So negative 44 plus and minus square root of negative 44 square minus 4 times a, 120. That's the c, by the way. A is 3. C is 120. Divided by 2 times 3. Alrighty. Okay. So this will just be positive 44 plus and minus square root of negative 44 square minus 4 times 3 times 120 is 496 all over 6. Okay, so here we will have two possible answers. The first is plus, and the second one is minus. So let's do both. Now the square root of 496 is approximately 22.27. Alrighty. So 44 plus 22.27 27 divided by 6 is approximately 11.045. And then this one, 44 minus 22.27 divided by 6. So this is approximately 3.62. Now, obviously, we will use the smaller one for this. Okay. So let's compute now the length, the width, and the height is 3.62. Okay, in terms of that value that we got, 3.62. So 24 minus 2 times 3.62 is 16.76. And then 20 minus 2 times 3.62 is 12.76. Right, so all we need to do is to multiply those three. 16.76, 12.76, and then 3.62. And that will give us the maximum volume. 16.76 times 12.76 times 3.62. There you go. So 774.16. So there you go. That's how you solve optimization problems in differential calculus. I hope you learned something. Thank you for watching. You have a nice day. Bye.